Hello everyone. So today we are going to solve the curve fitting with a linear equation with the example of the ideal gas. As you know, the ideal gas, according to the Charles law, the information that we have is the relation between the temperature in Celsius and the pressure in atm. So you have how many points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 points. We have 11 points of information that relates between the temperature and the pressure of the ideal gas. So for the example one, I want to make a plot of the data P versus T. P versus T. So it means if the temperature change, what's the pressure change? So we have worked this in the class and I'm not plot it again. So I want to use the plot that we did in the class. It looks like this. So the temperature is the x-axis. The temperature is the x-axis. And the y-axis is the pressure. When the temperature change, the pressure change. In y-axis, I did not plot beginning with 0 because the information, the data we have only between 0.9 and 1.3. So I choose to plot between 0.9 and 1.3. So I got the red dots, 11 dots, 11 red dots. What we have to determine is the relationship between pressure and temperature in this equation. What do we have to find is these two parameters, A1 and A0. What we're gonna do next is we have to use the equation in these slides, and you don't have to remember, but you just understand how to use it. So to determine A1, you have to find n. N is a number of data that you want to use. Now we have 11 points, but it's not necessary to use all of them. You just use 4, 5, 6, 7 points. It depends. It depends on how accurate do you want. Okay, N is a number of data. And next is SXY. SXY is here. SXY is the summation of the product between xi and yi. So you multiply x by y and then you sum all of them together. You get SXY. Then minus by SX and SY. So Sx is the summation of x. On the other hand, Sy is the summation of y. Right? And then this one, Sxx is the summation of x squared. You have to square x first and then sum all of them together. You got this, you got this one. And you subtract it by Sx squared. This one for A1. For A0, you have to use this equation. So you have the same equation of Sx, Sy, Sxx, Sxy. And you got this A1 to this and A0 to this one. Okay, So we begin with n. So go back to the example. The problem B, they ask us to determine the linear least square by using only 4 temperatures from 0, 30, 70, and 100. So they ask us to this 0, 30, 70, and 100. Alright, so we have just only 4 points to calculate the linear equations. So we have n equal to 4. So n equal to 4. So what is the next parameter we have to find? Sx. So we have to determine Sx. Let me delete this for the clean. So you have to find the Sx. Sx is summation of x. Summation of x. So we have x, x, and x, and x. So you add them together. You got these 200. 0 plus 30 plus 70 plus 100. You get 200. This one is Sx. The next is Sy. Sy is the summation of y. This one is y. 0.09, 1.05, 1.17, and 1.28. So you get these y, 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 and y. You get Sy here. Next, you have to find S, X, and Y. That means you have to multiply 0 with 0.94. And you multiply 30 with 105. And these two. And the last two. You get how much? 241.4. The last one, you have to find the Sx. It means you have to square x first and sum all of them. 0, 30, 70, 100. You got 15,800. Then you got these 4, 1, 2, 3, 4, and n. You put them back to the equation of a0 and a1. You put them back to a1 and a0. So I got a1 equal to 0.003345, and I got a0 0.9428, and finally I've got the equation of temperature and pressure. Look like that. How can I plot this back to the graph? So I have to plot the linear line, this line. So how to plot this? So I got t at 0. So I got t at 0. I've got this point. Let's see what I got. I got t equal to 0. I've got p 0.9428. And the next point, I got this one at t 100. I got 1.2773. That is the location of 2 points of the lines. So I connected 2 points with the line. That means this line has the equation look like this. And this is how we work to regress the data that we have. So this one is just a linear equation. And you can find this again in your exam, in the final exam. Have a good luck to everyone.